Hello friends, today we are going to study the Bode plot and we are going to determine the gain margin and phase margin and also the stability fault. Now let's take one example for this. At suppose G of S, H of S equals to 10 upon S into S plus 1 S plus 5. We have to convert this into the standard form. So let's convert. G of S, H of S equals to 10 upon S into S plus 1 S raised to 5 plus 1 and multiply by 5. Okay. So here it get cancels, 2 remains. So 2 upon S into S plus 1 S by 5 plus 1. This is it. This is the standard form. Now to obtain the frequency domain transfer function, we have to replace S by j omega. So G of j omega, H of j omega equals to 2 upon j omega plus 1 and j omega by 5 plus 1. Okay. Now we have to make a table of magnitude plot. So magnitude plot table. Here k equals to 2. So 20 log to the base 10 2 equals to 6.02 dB. Shifting you have for shifting, and also we have to draw a straight line at 6.02 dB. Okay. Now 1 upon j omega. Here we have to draw a slope of minus 20 dB per decade passing through 0 dB per decade at omega equals to 1. Okay. Now 1 upon j omega plus 1, here minus 20 dB per decade at omega greater than 1. Okay. 1 upon j omega by 5 plus 1, here also minus 20 dB per decade at omega greater than 5. Now since here there is no 0, therefore it will be there will be no 0. If a 0 comes in the new if a 0 somewhat s plus something take for example 2 comes, so it would be, here I have taken, since it is a pole over here, it is I have taken minus 20 dB. But if it is a 0, that is this value is in the numerator, so then we have to take plus 20 dB per decade. Remember this. Okay. Now this is our magnitude plot. We have done with the magnitude plot. Now for phase plot. We have to first write the equation. So phi equals to, now look at this function. Here j omega. Since here it is j omega, I will take here minus 90. If it would have been j omega square, I will take here minus 180. Now minus, this is j omega plus 1. Okay. So it will be tan inverse of omega by 1. This is j omega by 5 plus 1. So it will be minus tan inverse of omega by 5. If there would be s plus 2 in the numerator, so it will be plus tan inverse, that is plus tan inverse omega by 2. If it would have been there. Now it is not there, so I am not taking over here. Okay. Now we have to put the value of omega and get the value of phi. So at omega equals to 0.1, what the value of phi is minus 96.85. At omega equals to 1, the value of phi is minus 146.3. At omega equals to 2, it is minus 175.23. And at omega equals to 3, it is minus 192.52. Okay. Now using this magnitude plot table and phase plot table, we have to sketch the Bode plot on the semi-log paper. Now here, make it as 0.1. Okay. Then this would be 1. This would be 10, 100, 1000, and this is 10,000. Here 0 dB per decade. Here 20 dB, and here it is 40 dB. Okay. Downward it is minus 20 dB, minus 40 dB. Now at 1 by j omega, you have to draw a slope of minus 20 dB passing through 0 dB. So from 20 dB we will draw a slope of minus, that is downward side, at omega equals to 1. So let's draw it. This is it. Now again minus 20 dB. This was minus 20 dB. This is minus 20 dB. So in total we have to take a minus 40 dB slope. So 40 dB per decade slope. So minus 10, 20, minus 20, minus 40 till omega greater than, at omega greater than 1. But here it is 5. So we have to draw it at till omega equals to 5. This is the omega equals to 5 line. So minus 40 dB, that is still here. Take it, draw it. This is it. Now again minus 20 dB. So it minus 20, minus 20, minus 20. This is minus 60 dB per decade line. We have to draw it till infinity. So let's draw it. I've drawn it. See, this was the magnitude plot, but it is without k. This line is without the value of k. Now here I have told you, when we 20 log to the base 10 2, it is 6.02 dB. Now we have to do a shifting of 6.02 dB from here. So 6.02 dB means this is 6 from here. From here we have to take the do the shifting, this point here, here. This is the shifting, and also you have to draw a straight line from 6 dB. Draw a straight line from 6 dB. This is done. Now this is your magnitude plot is done. Now for phase plot, at omega equals to 0.1, it is the value of phi is minus 96.5. 85. So first 90 and this is minus 180. I'll mark the points: minus 99, minus 108, minus 177, 126, 135, 144, 153, 162 and 171. So minus 96 comes here, over here. Okay. Now at omega equals to 1, it is minus 146. Omega equals to 1, this is omega equals to 1, 146 means over here. Okay. At omega equals to 2, it is minus 175.23. 175 at omega equals to 2, this is 175. Okay. 171, 180, 175. And at omega equals to 3, it is minus 192. Omega equals to 3, 192, somewhere over here. Okay. Now we are done with the phase plot also. Now we have to get the phase margin and the gain margin. First, this is omega, this would the line which is what is the point at which your magnitude plot is coinciding with the 0 dB. Take that as omega GC, that is gain crossover. It is somewhat 1.1, 1.2 equals to 1.25. Now draw a straight line from that point downwards. Now for 5, this point is 162. Okay. Now your omega GC equals to, that is gain crossover frequency, equals to 1.25 radians per second, and your phi equals to 162 degree. So what is your phase margin? So phase margin equals to 180. Here it would be minus 162. So it would be 180 plus 5. So 180 minus 162. So it comes to be 18 degree. This is your phase margin. Now what is your gain margin? So the point at which your phase plot is coinciding with 180 degree, take that point as, this is the point, this is omega PC, that is phase crossover. This is something 2.2 radians per second. Alright, now take that line upwards. This somewhere here. Okay, this is the point. So name this point as M. M equals to, this is somewhere here, so it is somewhere here, over here, this line, so it is 14. Okay, so your phase crossover frequency equals to 2.2 radians per second. Yeah, M equals to minus 14 and gain margin equals to 0 minus M equals to 0 plus 14 equals to 14 dB. This is your gain margin. Now how to know the system is whether the system is stable or not? So if your gain crossover frequency is less than phase crossover frequency, then your system is stable. Okay, that's it. This is your Bode plot. For more videos, please subscribe to my channel. Thank you.